If you're a MATLAB user, you know you can make your own functions in addition to functions available from MATLAB itself using extension .m. You can do the same in AUXLAB using extension .aux. So just as an example, I'm creating a tone glide from 500 Hz to 1000 Hz for 1 second. That is A. And I'm applying the ramp function to smooth out onset and offset for 100 milliseconds. Let's look at the waveforms and play. Now, what if I want to apply offset ramping longer than onset ramping? Let's make a user-defined function. You need to create a text file with the very first line beginning with a keyword function and output arguments, one or more, and function name, parentheses, and input arguments, one or more. Then save it as the function name.aux. So make a new file in a text editor, begin with keyword function. Output argument is going to be y. Function name is going to be ramp2. We have 3 arguments, x is input signal, and 2 time parameters for onset and offset duration. There are many ways to do this. This is just one way to do. I'm going to just create 2 handing windows with different durations and apply that for the beginning and ending part of the signal. I'm also adding comment, 2 forward slashes, just like C++, letting us know that D1 and D2 are in milliseconds. How many sample points we need for the ramping duration. So here I'm using the function getFS, that is a built-in function. D1 times getFS and divide by 1000 and apply the round function to make it integer. Same for D2. And I'm making 2 handing windows, smoothing 1 and 2. The way hand function works in AUXLAB is as a window function, it applies to a different signal, which is a unit signal in this case, a signal with all ones. And notice that I multiply 2 for endpoints 1 and 2. That's because handing window has both rising and falling period. And we are going to need only half of it. For smoothing 1, it is the first half. For smoothing 2, it is the second half. Also notice the dot notation so that you don't have to type long variable name again on the right hand side. Then make a copy of x for y. Then apply the first handing window at the beginning. Using the compound operator multiply equal. The beauty of AUXLAB, you don't worry about sample sizes when you multiply. And second handing window at the end. Notice the time shift operator for smoothing 2, shifted by the duration of x minus d2. That's it. Then save the file as ramp2.aux. Put the same location as the application, which is here. So we see the file here, ram2. So that's the folder. Now everything is ready. We can try. Now B is going to be a.ram2.100 and 300. Hey, there's an error. Something must be wrong in my code. On line 11 and column 4, it says it requires an audio signal as the base. So this is time to use debugger. So where's the debugger? You see the icon here, D and bug, that's debugger. And click the file. Now debugger is open. Alright, you see the check marks here on the first column, set breakpoints here. Let's put a breakpoint on line 9 and run the program. You see the execution stops there on line 9. You can see all the variables here. Check their values at this point of execution. You can make plots of these variables. Smoothing 1 for rising, smoothing 2 for falling. And notice that they have different sample size. Now press F10 to step to the next line. Press F10 again to go past line 10. Make plot of y, you see there's a nice rising onset for y from line 10. Press F10 again. Oops, we got an error again on line 11. That's okay, we can do it over. Notice that the named plots for smoothing 2, y, and smoothing 1 behind y remaining on the screen. We had these variables inside the debugger, but we just got out of the debugger, so they no longer exist. but they still remain here for your reference only with a label of the function name ramp2 in this case, so you know that they are not from this world. In previous versions of AUXLAB, I automatically closed these plots on exiting the debugger, but it's probably better to leave them on the screen, close them separately if you want to. Now back to line 11. What is wrong on line 11? We need to figure out. On line 10, we multiply smoothing 1 on Y, and it worked okay. But on line 11, when we try to multiply the time-shifted version of smoothing 2 on Y, we had an error. If you think about it, that makes sense because in order to use time shift operator, you have to have audio signal. You cannot apply time shift operator to non-audio variable. How do we fix it? Use another function that converts non-audio to audio. So in this case, you can just put dot audio right after smoothing 2. So let's go back to the editor, add dot audio on line 11. Then save the file and try again. Alright, so run again, stop at 9 and press F10. Now on line 10, make plot of Y, press F10 and F10. Ta-da! That's what we want. Now, line 11 is complete. We are about to exit the debugger, but before you do that, you can stay here and check other variables if you want to. When you are done, press F10 or F5 to exit and go back to the main scope. The variables in the debugger are all gone, and you see only A and B, the variables in the main scope. Plot them. Yes, that's what we want, the new B. So we just looked at the basic features of our AUXLAB debugger. We only scratched the surface here. For more real application examples, stay tuned for the next video.